So here is another question on relative velocity. So the question is that a swimmer's speed in the direction of flow of a river is 12 kilometers per hour, and against the direction of the flow the speed is 6 kilometers per hour. Calculate the speed of the swimmer in still water and the velocity of the river flow. Okay, so this is one particular type of question. This question can be, also framed in a different way in the form of boat and stream or river and swimmer. So in any way this thing can come. Okay, so here we have to understand some basic concepts. So first of all, there is whenever swimmer or boat or stream or river it comes into play, there are two things that you have to understand. First of all, there is one thing called as with the flow, and another thing is against the flow. Okay, so with the flow means the velocity of the river is, let's say, in this direction, the velocity of the river, and the swimmer, let's use a different ink, the swimmer is also moving in this direction. The velocity of the swimmer Vs, velocity of the river Vr. So the net velocity of the swimmer is velocity of the swimmer plus velocity of the river. Here Vs is the velocity of the swimmer, only his velocity, as if he is in still water, the velocity of the swimmer, that is, and Vr is the velocity of the river. So when the swimmer is swimming with the flow, okay, in the direction of the flow, both these velocities they add up. Okay, suppose the swimmer is swimming in the opposite direction. Okay, so same thing, the velocity of the river is in this direction, Vr same, but the swimmer is swimming in the opposite direction. Okay, in this direction, velocity of the swimmer. So in this case the net velocity of the swimmer is equal to Vs minus Vr. Here the river is opposing the swimming motion of the swimmer. Same thing can be applied for boat and stream. Okay, upstream, downstream. Upstream it is moving against the flow of the stream, downstream it is moving with the flow. Okay, so same thing. So here it has been given that a swimmer's speed in the direction of flow of river, that is this case, it is equal to how much? 12 kilometer per hour, and against the direction of the flow it is how much? 6 kilometer per hour. So Vs plus Vr is equal to 12, Vs minus Vr is equal to 6. If we add them together, this will get cancelled. 2 Vs is equal to 18. That implies velocity of the swimmer is equal to 9 kilometer per hour. This, and velocity of the river is equal to how much? 3 kilometers per hour. This. Okay, so here this is the velocity of the swimmer in still water, and this is the velocity of the river flow of river. Okay, so Always remember these concepts whenever you are solving the problems like this. Okay, so here is another question. So it has been given that a boat can travel with a speed of 13 km per hour in still water, and if the speed of the stream is 4 kilometers per hour, find the time taken by the boat to go 68 km downstream. So like we solved the previous question where it was the swimmer and the river, here also there are two important concepts. First is upstream and downstream. So upstream is same as against the flow, and downstream is same as with the flow. So in case of upstream, the velocity of the boat, the net velocity is equal to the velocity of the boat minus the velocity of the stream or the river. Okay, this. And in this case, the net velocity is equal to the velocity of the boat plus the velocity of the stream. So here it has been given that the velocity of the boat in still water is 13 kilometers per hour and the velocity of the stream is 4 kilometers per hour. Okay, speed, velocity, whatever. So here downstream 68 kilometers, which means this net velocity will be equal to this Vb plus Vs, that is equal to net velocity downstream is equal to 13 plus 4 kilometers per hour, which is equal to 17 kilometers per hour. So the total time taken for the trip downstream is equal to the total distance, which is 68 kilometers, divided by the net speed downstream, which is 17 kilometers per hour, which is equal to 4 hours. Here, this 4 hours. So here the time taken by the boat to go 68 kilometer downstream is 4 hours. This. Okay, so same as I said, different types of problems can come up. It can be framed in different ways, whether in the form of swimmer, river, stream, boat, whatever. So you should understand the basic concept. Okay, upstream, downstream, against the flow, with the flow, all that. So here is another question. So it has been given that a motor boat whose speed is 15 kilometers per hour in still water goes 30 kilometer downstream and again comes back upstream in a total of 4 hours 30 minutes. Find the speed of the stream. So again, very simple. We have to understand the concept of relative velocity when it comes to upstream and downstream. So when it is upstream, that is against the flow of the stream, the net velocity is equal to the velocity of the boat minus the velocity of the stream. Okay, this. And then when it is downstream, that is with the flow, the net velocity is equal to the velocity of the boat plus the velocity of the stream. This. Here the velocity of the motor boat in still water is given 15 kilometer per hour. Let the velocity of the stream is equal to x kilometer per hour. We assume it. Okay. So it has been given that this motor boat, it goes 30 kilometer downstream and comes back same 30 kilometer upstream in a total of 4 hours 30 minutes. So time for downstream trip is equal to 30 kilometers divided by the downstream speed or velocity, which is Vb plus Vs. Vb is 15, Vs we have assumed x, so it is 15 plus x kilometer per hour. This is the time. Time for upstream is same 30 kilometers, but here the velocity or the speed is reduced, 15 minus x, Vb minus Vx. Vb is 15, x we have subtracted. So according to the question, this total time, that is t downstream plus t upstream, is 4 hours 30 minutes. That is 4 plus 1 by 2 hours. Okay, that is 9 by 2 hours. So here it is 30 by 15 plus x plus 30 by 15 minus x is equal to 9 by 2. Okay, that implies here 15 plus x into 15 minus x, it is 30 into 15 minus x plus 30 into 15 plus x, that is equal to 9 by 2. So here it will be, we are taking it here, 450 minus 30x plus 450 plus 30x by 15 square minus x square is equal to 9 by 2. A plus b, a minus b is a square minus b square. Okay, that implies this gets cancelled. 900 by 15 square minus x square equals to 9 by 2. That implies cross multiplication, 1800 is equal to 9 into 225 minus x square. That implies 1800 is equal to, this one will be I think 45, 2025, I think 2025 minus 9x square. That implies 9x square is equal to 2025 minus 1800, which is equal to 225. That implies x square equal to 225 by 9, it is 245 25, right? Yes, 918 4 yes, 25. That implies x is equal to plus minus 5. So x here will be 5 kilometer per hour, which is the speed of the stream. Okay, this. So the speed of the stream here is equal to 5 kilometers per hour. Okay, so here the basic concepts related to upstream against the flow and downstream with the flow you have to understand. Only then you can solve these type of relative velocity problems. Okay. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.